Question 8 asks us to solve tan squared theta plus 6 times tan theta plus 5 equals 0. And it asks us to solve it for two different cases. Case A, where theta is greater than or equal to 0 and less than 360 degrees. And case B, just a general solution. So the first thing we want to do is think of any possible restrictions we might have on theta. And in this case, we have the restrictions that theta cannot be equal to 90 degrees plus 180 degrees times n, where n is an integer. And that's because at these points, 90 degrees and every 180 degrees plus or minus from that, tan of that angle is undefined because you end up getting something over 0. If we remember that tan theta is y over x. So these angles are lying on the y-axis, and so theta, or tan of theta is undefined for those angles. So we just have to make sure that when we answer this question that the angles we get don't fall in this number range. So next thing we want to do is to make this a little bit easier on ourselves. What we have is tan squared theta plus 6 tan theta plus 5 equals 0. And what I'm going to do is I'm going to say that tan theta is equal to x. So then I can substitute x in for tan theta here and hopefully make this a little bit easier to look at and solve. So substituting that in, what I get is x squared plus 6x plus 5 equals 0. Okay, and so now I want to factor this out, and I can see that what I want is two numbers that multiply to positive 5 and add to positive 6. And so that's going to be positive 5 and a positive 1. So from this I can see that my two solutions are that x is equal to negative 5 and x is equal to negative 1. And so now I can substitute tan theta in back for x, and what this gives me is that I have one option where tan theta is equal to negative 5 and another solution where tan theta is equal to negative 1. Okay, so starting with this one, to figure out what theta is equal to the inverse tan of negative 5. And if you plug that into your calculator, what you get is approximately, it's a long decimal, but approximately negative 78.7 degrees. And so what this means, if we draw it on a coordinate plane, is that this is 0, this is 360 degrees, and over here we have 180. What we have here, we're looking for quadrants where tan is negative, and that's going to be this quadrant here, quadrant 2, and quadrant 4 down here. And so this is going to be the arm, and what we figured out here is the reference angle, which is 78.7 degrees, is this angle here. But what we're really interested in is the angle around this way. So to figure that out, we simply say that theta approximately equal to 360 degrees here minus 78.7 degrees, and that's going to tell us this angle here. And that ends up being approximately 281.3 degrees. But remember that tan is also negative up in this quadrant, so we have another solution up here that's symmetrical to this with an angle here of 78.7 degrees. And to figure out this angle, it's this one here we're interested in, what we do is say that theta is equal to 180 degrees sorry, 180 degrees here, this line, minus 78.7 degrees. And that ends up being 101.3 degrees. Okay, and so we have two angles for theta here. Let's go back to this solution over here. So, sorry, I've just moved that tan theta equals -1 over slightly to give myself more room. So we have tan theta equals -1. Again, we figure out theta. It's tan, inverse tan, -1. And that gives us theta is equal to -45 degrees. And so, again, looking at what this looks like, we have an angle here in this quadrant where this is 45 degrees. And then another one here where this is 45 degrees. But what we're interested in is this angle and this one. So to figure that out, we say theta is equal to 360 degrees minus 45 degrees. That's 315 degrees. And theta is also equal to 180 degrees minus 45 degrees, which is 135 degrees. Okay, so these are solutions for theta when theta is greater than or equal to 0 degrees and less than 360 degrees, because these are the options in one full circle on this coordinate graph. So for part A, we can say that x is equal to 101.3 degrees, 135 degrees, 281.3 degrees, 350 degrees. That's just taking all these values, putting them together. For part B, I'm just going to separate this off a little bit. What we want is a general solution that works for all possible values of theta, not just within this range. And so to do that, basically what we're doing is finding angles that are coterminal with these ones that we found here. So we know that we're basically adding one full revolution to land on each arm again. But in this case, we have straight lines here, so we can pick one of these angles in each case and basically add 180 degrees continuously to get all possible values of theta. So in this first case, what we have is basically theta is equal to 101.3 degrees, and we can find, or we can express all the other possible angles in this case by adding k, which is any integer, times 180 degrees, and that's going to fall first on, so if this is the 101.3, it's going to fall here and then continuously fall on these two arms when we add multiples of 180 degrees. So that encompasses all possible values of theta. In this case, we can also write this in radians. Right now it's in degrees. And to do that, if you remember, we can convert degrees to radians by multiplying by pi over 180 degrees. So multiply by pi, divide by 180 degrees will give you radians for these angles. And converting that, we can write this as 3 pi over 4 plus k times pi. Pi is equal to 180 degrees. So that's just two ways of expressing the general solution, or one part of the general solution, because we also have to consider this case where we can do the same thing and say theta is equal to the smaller angle 135 degrees plus k times 180. Oops, sorry, I've messed this up. I've switched them around. So Converting this to radians actually gives you theta is equal to 1.77 plus k pi. In this case, when we convert to radians, we get 3 pi over 4 plus k pi. And we have to specify that k is any integer. And so these statements are our general solution to this equation here. And these answers give us the answers for question 8.